surfaces or the taxiways, etc., that results in little to no disturbance of the pavement structure, resulting in the users of the facility being able to utilize it almost immediately after the testing is completed. Now, this differs to destructive testing, where you would actually be disturbing the pavement structure. So, for example, if you were to have a test pit, as you can see in the image, you may have to disrupt the pavement structure, you may have to disrupt the flow of traffic naturally. You may have to incur a lot more logistical issues related to traffic control, notification to your road users, notification of road closures, and usually after the critical thing with the with the destructive testing is that immediately after the road or the runway, as the case may be, may not be available for some time until such repairs to the pavement surface are undertaken that would facilitate the normal operations. So therefore, right away, intuitively, we can see benefits to non-destructive testing, whether it be using laser type scanners or impulse type equipment such as falling wave deflectometers, which we will discuss a little bit further on in the presentation. But right away, you can see some direct benefits to the use of non-destructive pavement testing. Right, so one of the things that is pretty obvious is that there's less inconvenience to the user. So you do the test, and as you saw in the first image, which was actually a ground penetrating radar, as soon as the vehicle passes by, you do nothing to the road surface. You can proceed with your with the operations on the roadway, and depending on when and where it's done, the road user is actually none the wiser as to what test, if any test, is being done on a particular roadway. It's also less inconvenience to the operator because, you know, right away, for those of us here who may be operators or maybe consultants, you know what a logistical task it is to coordinate the activities with the traffic police, put the notices in the press that there's going to be disruption to work, not least for the fact that you also have to engage staff in an operation over a lot longer period. So there's also less inconvenience to the operator, whether it's a public sector or private sector client. The third one, which may not be as obvious, but it's rather intuitive, is that you tend to have a higher sampling rate. So for example, you can imagine if you were only using destructive testing over, let's say, a 50-kilometer stretch of roadway, and you need to understand what is happening at every kilometer, then 50 test pits and the logistics around that could be a nightmare. Well, the equipment that you see in the background there, and FWD, we were actually able to, in a 6-hour period, undertake 46 kilometers of testing at a particular interval. But if you were to just use the example of a test pit every kilometer, and if you were to do one sample every kilometer with this piece of equipment, then you would, in no time at all, you would be able to complete your testing and get a, not an accurate, but a fairly reasonable estimation as to what the condition of the road structure would be. This one is where the two types of technology separate themselves. The cost effectiveness, again, intuitively unrelated to the fact that there's less disruption to the travel roadway, and this includes airport runways as well. So you know, you could imagine doing destructive testing on a runway and trying to get it back up and running so that flight operations at a busy airport will not be severely inconvenienced. Besides that fact, the cost effectiveness of one, the speed at which you can actually get the sampling, and secondly, the minimization of the overheads associated with the project, means that you can get a lot more bang for your buck. Now, I'd just like to state that it does not mean that destructive testing is bad or is not necessary. Yes, there is a time and a place for destructive testing, and usually it is done in conjunction with the non-destructive testing. The advantage that you have is that the non-destructive testing allows you to have less disruption to your operations, reduce your costs, while giving you a fair to excellent picture of what you actually have with your airport or your roadway pavement structures. So the two go hand in hand. Typically, what we do on our projects is that we tend to use a lot of destructive type testing, such as the test pits, the cores, so that the sampling rate that you would have and the wider picture or a lot more of what you can capture is not actually available. And as such, there can be gaps in the quality control or the quality assurance process. Right, so that said, why would we do testing anyway? Well, a picture speaks 1,000 words. So we see here severely potholed roadways, and I'm sure this image or similar image would be very familiar to a lot of us here. Our Caribbean roads tend to not be very well maintained for a very long period, far less to survive the 20 was designed as such. And as we go into the subsequent slides, we'll get to understand why this is so and why the non-destructive testing in particular is particularly important to avoid scenarios like this. So maintenance and repairs tend to be very costly due to late interventions, again associated with the lack of routine maintenance management systems, other types of testing procedures that could normally prevent this sort of scenario. The third, and this is something that I hope that the young engineers among us really embrace, is the lack of climate resilience and sustainable solutions in pavement design. So, for example, how we cater for drainage, the types of aggregate we use in the mix that will facilitate rapid runoff, for example. Some of these issues that we have to pay particular attention to as we have the effects of heavier rainfall, or even the extremes of the dryness, where we have, for example, our clays that may crack. We have severe cracking issues and so on. Notwithstanding that, even the existing pavements, some of them that would have been designed for many years ago, sometimes you see the effects of the climate hello? Okay. Yeah, sometimes we see the effects of the climate change on fairly rapid deterioration on pavements that would have been in fair to good condition over a number of years, with no other plausible explanation but the fact that the climate resilience really is an issue in that regard. And then I want to throw something into the mix here that we all know it's sort of the elephant in the room, but must go in conjunction with any type of testing regime program. And that has to do with the impact or the effect of heavy and overloaded vehicles on roadways that suffer from all of the issues described in 1 to 4. And across the Caribbean, you would have heard the moderator indicate that I would have done work in a number of Caribbean territories. And without fail, all of the Caribbean territories suffer from this particular problem. It's not unique to Trinidad and Tobago by any stretch of the imagination, but we tend to have a situation where we have vehicles that carry sometimes twice the legal load, and so the real impact of that sometimes is not captured until such time as we have to undergo critical expenditure. And when you do surveys, for example, axle load surveys or surveys that involve the weighing of trucks, that we then understand that, wait a minute, even if I were to design my roadway for climate resilience and do whatever maintenance program, if I do not spend the time and effort in arresting the issue of overloaded vehicles, then we may be significantly reducing the pavement life. Just to close off this point, I did an axle load survey, a heavy vehicle weight load survey somewhere around the COVID period, and based on the loads that we would have encountered, we did not expect the design life or the pavement life to exceed 7 years for a 20-year design life for that particular road pavement. So in other words, the client would have spent tens of millions of dollars in reconstructing the particular roadway, with the only expected benefit being that it would last for perhaps 7 years at maximum. Okay, right. So into the meat of the matter with respect to non-destructive testing. So rotting, and for those of us unfamiliar with the term, rotting relates to the cross-sectional defect that you see typically at intersections where you have the wheel path of the vehicles making impressions in the roadway. And it is most noticeable during a rain event, where you tend to see these what appears to be long streaks of water almost forming a drain along the wheel path of the roadway. So that is what rotting is, that deformation that occurs across the cross-section, and is usually, well, not usually, it is as a result of heavy vehicles, particularly overloaded vehicles, as described in the previous slide. Now, how does non-destructive testing come into play here? Well, there's a piece of equipment called a laser profilometer. And again, we will you'll see a little bit more of the equipment as we go through the presentation. But this chart here, which you can, if you were to Google rotting characteristics or rotting limits, you will pretty much see this this template on any website or any traffic engine or pavement engineering handbook. But what it essentially tells us, if we look very closely, is that for rot depths of up to 10 millimeters, the naked eye cannot observe any deformation in the pavement. So it's only when you get to be a range of between 10 and 20 millimeters, that's the fair range of the pavement condition. So you're out of the very good, you're out of the good, you're into the fair, then rots in the pavement can be observed. So notice, they were very clear, no rots can be observed in the pavement and there's no impact on road users. So there's deformation taking place, in other words, that you cannot see. A laser profilometer, as the term suggests, uses a laser that checks the profile of the roadway, both the cross-sectional profile and the longitudinal profile. So what this instrument allows you to do is to see or observe the commencement of the deterioration. And as we see in the next slide again, for which the pavement engineers will be adequately familiar with, we recognize that once you get into the fair region of the deformation, it's only a matter of time before, you know, the pavement just goes from fair to very poor. It's a relatively short time compared to the time it takes to go from very good to fair. So it means, therefore, that we should be examining our pavements at regular intervals shortly after construction and regularly after construction to ensure that we detect when the deterioration begins so we can arrest it as quickly as possible. So as I jump into this slide, this here gives you an idea of, or puts graphically what we saw in the table previously. So the fair region here, they have slightly different lettering for it, but it's pretty much the same. So the fair region I was referring to is the yellow region, where you actually begin to see the deformation. But look at the deterioration on the curve. Look at the slope of the curve. So you have a shallow slope up here. Then when you get into the fair region, you're like the roller coaster that you know starts to descend from the top. Once you get here, then you have rapid deterioration. Now, why is this significant? And again, think about the project cycle for most of our projects trying to go across the territory. So a defect is observed in the pavement, usually around this time when you can actually see it. So then, whether it's the district engineer or a client or a public private citizen makes a complaint, it goes to, let's say, the Ministry of Works or whatever the client executing agency may be. The engineer goes on site, has a look, he may do a condition survey, then you decide, okay, this thing perhaps needs some attention. So, okay, you escalate it to the supervisor, the director of highways, the permanent secretary, as the case may be. Okay, a proposal is done for a project. Perhaps it goes to cabinet, depending on how costly it is, or it may go to the board management committee if it's one of the quasi-state enterprises, as the case may be, some approving authority. So then, yes, a budget is approved, and then we go to tender for a consultant to do the design for the repairs. Then the consultant goes, does his or her work over maybe a 6-month period, then develop a bill of quantities, scope of works, designs, drawings, everything. Then that goes out to tender, and that tenders are evaluated and so on. By the time we're complete with that, an inordinate amount of time goes by, and I think everyone here understands that project cycle. So what you find is that what would happen, and look carefully at the rate of deterioration here, within what is this, maybe 2 years or so, we go from a fairly flat portion, let's say 3 to 4 years, a fairly flat portion of the curve to a relatively steep portion of the curve. So what that means is that by the time we observe, we issue the instructions to design, go to tender, etc. By the time we close that process and the contractor is on the ground, we are usually in this area here. And I kid you not, I have actually experienced this in the 20-something years I've been in practice as a supervising engineer. I've seen the pictures before the design stage where the condition of the roadway was markedly different at the award of construction compared to when the initial problem had surfaced. And as such, what you find then is that you have variations, you have redesign, change orders, you have increased cost naturally, you have increased time for the project. And so you end up in something that is really unpalatable to everyone, the road user, the client, the taxpayer, everybody. So with the non-destructive testing instruments that are available on the market, if you were to capture deterioration as it starts up here, look at the remedial action that is required. Crack filling, maybe some chip sealing, fog sealing, but essentially solutions that are in the 4 to 5 digit region. Literally $5,000 to $10,000, sometimes $20,000, depending on the length of the roadway that you have to seal. But when you get into the replacing hot mix with hot mix asphalt or milling, as we see on some of our roadways, etc., using hot mix asphalt overlays, you're talking nothing less than 7-digit figures. So then ask ourselves the question, does it make sense to be in this area or should we be in this area for saving a lot more money and utilizing those funds where they can be better utilized for other road improvement works, etc., as the case may be. So you see, here we see it's pellucidly clear the need to ensure that we have these tools and these technologies in place such that both, and again, this is for roads and for runways as well. So there's no distinction where this is concerned. It's pretty much the same. We can utilize the technology to ensure that we have value for money, we have longevity of our pavements, and that at the end of the day, the users and the operators are comfortable in the space that they're in. So these are two examples of equipment that we utilize in our company and we utilize across the region. On the left is the laser profilometer I was referring to, and on the right is a falling weight deflectometer. In fact, this is actually what is called a heavyweight deflectometer. The difference between the falling weight is that the heavyweight can actually mimic aircraft loading so that you can actually use this for testing airport runways. So we have used this, for example, in Guyana to test to do analysis of the runway and the aprons and taxiways and so on behalf of the Chedijagan Authority. So this was the way this piece of equipment works is that it's you see the pistons at the top, it drops a load from a known load from a known height, and the impulse that is generated is picked up by geophones on a rail that at set distances, and based on the deflections, then you know how stiff or how strong the various sublayers are. Right? The laser profilometer on the left, on the other hand, deals strictly with the surface. So that nice bar you see across there has a number of lasers, and you'll see a little bit more of a graphical description of all of the equipment there, of the equipment in our subsequent slide. And this is what is used to actually measure things like rotting, as you would have described previously. All right. So why is there a need? And this relates to all users typically in a project cycle. The users, the client, the financiers, as the case may be. So what's the client's need? Well, all clients want to ensure that they get what they pay for. All right, both immediately in terms of what is constructed and it endures the test of time. So clients, for you, wouldn't it be nice to know that prior to handing over your certificate of substantial completion, that you have some empirical evidence that the contractor did what he promised to do? Well, I'm sure the answer is yes. And as we go to the contractor subsequently, we'll see where it actually benefits both parties. So for the contractors, quality control and avoidance of disputes. And this is something, again, across the territories, without fail, we tend to see this happening over and over. So clients are complaining 6 months after they pave the roadway that the roadway is deteriorating. But then the contractors are stating, but Mr. Client, I built the roadway correctly, but you remember that thing about the heavy vehicles you saw in the slide with the potholes? Well, yes, well, you have no control over the trucks that are coming on your roadway. You're allowing trucks to be significantly over the legal limit, and then you want to pin the liability on me. So then I ask you all the question, who is right and who is wrong? Can anybody be right or wrong? Well, how can you know? Well, one of the sure ways to understand that is to ensure that you have a testing mechanism that allows you to certify that whatever was built is actually what the parties agreed to be built, and that there's no dispute at the point of handing over of the particular piece of infrastructure, whether at the point of substantial completion or at the end of the defects liability period. So in a lot of ways, and based on my practice in the US, I can assure you that these standards are adopted just for that precise reason. And it saves a lot in court costs and arbitration costs and disputes back and forth, late payments because clients don't want to approve contractors' payments, and it avoids messy situations like that. So again, we looked at the operations aspect of it, where we actually have a pavement that is built, but we also look at the quality control and the taking over aspect of actual contracts, where we can adopt a mechanism that will facilitate the seamless transfer of the and help to avoid issues as you go as you complete the project. So of course, consultants and project managers for quality assurance and verification of the contractor's designs even prior. So you utilize the equipment at the various stages of the project if it's a particularly long project, so that you can certify, well, okay, this is fine. So prior to even reaching to the client, there can be agreement by the parties, that one that advocates for the client and the other, the contractor, that things have been done according to the specifications. And lastly, of course, not to mention the finances. People like I know in Trinidad and Tobago, we typically, the Ministry of Finance usually funds our projects, but in those territories where you have the IDB, the Caribbean Development Bank, World Bank, and so on, these are things that they can request to actually validate the results that were presented by the contractors and the clients for final transfer or disbursement of the various tranches of funds for the projects. Okay. So essentially, this is what a laser profilometer looks like. Okay, so you would have seen from the picture of the vehicle in our possession. So you have what you call a transverse profile logger, which essentially you have a series of lasers going across. And again, you'll see some more detail in a subsequent slide, where you have, as the vehicle drives along, the measurements are taken every 25 millimeters along the roadway. Now, if you understand 25 millimeters on a, let's say, a 50-kilometer roadway improvement project, that is, pretty refined sampling. But the thing is, it allows you, because of the lasers, to pick up things like, again, the cross-section of the roadway. So if there are any defects in the cross-section, it allows you, because the laser can penetrate the cracks, it allows you to understand or to see where cracks are developing along the roadway. As well as the lasers that you see behind here allow you to understand what the longitudinal profile looks like. So as you drive along, what the grade is, whether you're going uphill, downhill, whether there's variation in the grade or anomalies in the variation of the grade. The lasers also allow you to check the quality of the aggregate within the pavement surface. So both the micro and the macro texture, which I'll explain a little later on. What you call the video logging modules, or basically right-of-way cameras, allows you to get a visual impression or to visually record the roadway as you go along. So as you begin to get defects with the from the laser profilometer, you can actually have a video log of where those are, and you can actually see the extent of the defects. It allows you also to pick up things like, signage on the right-of-way, the quality of the drainage, as the case may be, things that the laser profilometer would not pick up, but is useful information, especially when you're doing a condition, what you call a pavement condition survey. You also have a high resolution odometer, which works along with the GPS. Our GPS module is slightly different to this one, but again, it works the same in principle. So you have your geolocation and you have the high resolution odometer, which gives you precise measurements as to exactly where you are on the roadway. All right. And finally, and this is a module we don't have just yet, but we acquire in the future. It's called a laser crack measurement system. So you use LiDAR, and what this does is that it picks up the depth of the cracks that you would have picked up from the laser profilometer. So as the laser profilometer, as the transverse profile logger goes along a particular roadway and picks up the cracks, the LiDAR actually is fine enough to actually map the profile of the crack so that you can get the depth of the crack and understand exactly how far these cracks have penetrated into your pavement layers, especially if you're considering whether milling is an option or you need to do some shallow patching or full depth pavement replacing, as the case may be. All right, so this is essentially what a typical laser profilometer system would look like. And over the next few slides, I'll just go through a little bit more detail how each of the components work and how they support the general management of pavement and the quality control during construction. So remember we spoke about rutting previously, what rutting is. So with the 15-point laser system at the front, you're able to map the cross section of the roadway. And of course, based on the time it takes for the laser to return to the sensor, then that will indicate, well, you know, what the depth of that particular point on the roadway is. So you basically get a mapping across the roadway, and that will indicate what the rut profile is, and you can obviously obtain the rut depth from there. This is just a screenshot of what the operator would see in the vehicle. So so right here you have the right-of-way camera. So you have left, well, this one, we have 2 on ours, this one has 3. So you have the roadway in front, the sidewalks on the side, and the right-of-way on the left. To the rear of the vehicle, we have what is called a high-resolution camera, which picks up, which is able to detect microscopic cracks as well. So in place of the LCMS, we actually have a high-resolution camera. So you're able to see, again, cracks that you cannot see with the naked eye. All right, and in support of the laser profilometer. This here is what the lasers would reflect. So this would be the rut, the cross-sectional profile of the roadway as you drive along. And then you have the IRI is what the operator would see. So essentially, this is what the panel would look like in the vehicle. And so as you drive along the vehicle, the operator will observe these parameters and, of course, log any issues that they may see, and this essentially just make sure everything is working okay. Right. So essentially, in summary, the laser profilometer would be used for IRI verification, which is roughness, International Roughness Index, macro texture, which deals with the quality and the placement of the aggregate in the mix as laid on the roadway, the cross-sectional profile, and crack mapping. So just quickly, just to go through for those of us unfamiliar with this chart, this is basically the IRI index or the roughness index measured in units of either meters per kilometer or inches per mile. And it's essentially an index or a measure of the degree of roughness of the roadway. So the lower the value, the smoother the road, higher the value, obviously, the higher the roughness. So typically for pavements, you would want to have them more freshly paved roadways. You want to have them as low as possible generally. You won't get to 0, but maybe about half, 0.4, that kind of thing, up to maybe 1.5. If you're into 2, well, then, you probably need to do some remedial work. But generally, the new pavements, you can get typically between half and 1.5. That would be considered acceptable. Sorry. And as they begin to deteriorate, well, then, airport runways will have, because they have a higher standard, they tend not to want to go beyond 2 before you commence some sort of rehabilitation work. But new pavements, generally, you want them to be between 1.5 and maybe 3 maximum. Once you start going to 3, then probably looking to do some corrective work. And again, as you go higher up, you get rougher. So, you can see what is characteristic of a damaged pavement or unpaved roadways, as the case may be. All right, so you have heard me refer to microtexture and macrotexture previously, which are some characteristics of the aggregate in the roadway. So the microtexture essentially is a measure of the quality of the adhesion between the aggregate and the rubber and the tires, and it's essentially a property of the aggregate itself. So if you see in the background there, you see the microtexture really refers to the the texture of the surface of the aggregate that assists with skid resistance. The macro texture deals with the texture depth and the interlocking of the aggregate in the road.
In academia, in research.
Hello? Right. So the macro texture deals with the interlocking of the aggregate and how that actually facilitates the drainage and runoff of water on the roadway. So the laser profilometer, because of the high resolution of the lasers and the spacing, is actually able to give an indication as to how the aggregates are positioned within the road surface, and as such, and there are specific values for these, which then allows you to determine whether or not it's an acceptable mix or has been laid acceptably, and it's usually a property of the mix, right? Whether the mix was done according to the specification or the mix design, and whether it has been laid appropriately, that would facilitate runoff as opposed to pooling, which, over time, as microscopic cracks develop, then you get into the other layers and you begin the destruction of your pavement. Right, so this is just some snapshots of what the output would look like for a typical assessment once you post-process the data. So here, this would represent a slice of the cross-section of a roadway. So for example, you would see here's a rut. So you see the characteristic shape here of the roadway. And then look at this, you're actually able to see a crack in the roadway. So this would more or less have been used by the LCMS, which is the option that we don't have. But essentially, if you were to look in plan view, which we'll see on another slide, you will be able to see exactly the line of the cracks. But this here gives it 3D, so you actually have any crack depth. Okay, so as you would see across here, the various slices, this would be left and right wheel path. So you're able to see the rut on one side, fairly okay on the other side, then the pavement tapering off on the side, and here you see a crack developing. So with this information, then you can probably, as you see the slices going down there, you can see perhaps the crack is continuing for maybe a few meters down the roadway. So right away there, you can tag this area for future repairs. Right. This here just shows, well, what we refer to as shoving. So sometimes after a rut, then you would see the asphalt sort of making a hump on the side of the roadway. So the profilometer will also pick that up. So then you can, again, ascertain what sort of treatment you want to have for that particular event. And the crack mapping, which is what you would get from the 2D lasers that you have at the front of the vehicle. The colors here, you don't get any colors, but you'll actually get the information from from a combination of the GPS and the lasers. So you're able to then superimpose this on any GIS software and then actually map and color code the cracks depending on the severity, which will typically be the width of the cracks. Okay, and then you can mark them accordingly. So in a nutshell, the profilometer essentially allows you to obtain critical bits of information, and not just critical bits of information, but critical bits of information at an early stage in the pavement deterioration cycle, such that you don't incur unnecessary costs. And that fundamentally is the message that I would like most of us here to go away with, that there are tools and techniques that are available to allow us to preserve the quality of our infrastructure, whether it be an airport runway or a road pavement. They are relatively inexpensive, and I'm saying relatively, of course, relative to the reconstruction of an entire runway or roadway, that can be employed to ensure that we have facilities that can last the design life. Okay. Right, so I just want to go on a little bit to the following deflectometer. I know I've been talking for quite some time, so I don't want to lose you a bit, and I'm sure you'll probably have a number of questions afterwards. So the heavyweight deflectometer, as I described, so it's an impulse type piece of equipment where you have, if I don't know if you can see it clearly from your end, but we have a load stack similar to like weights in a gym, that you can select the loads depending on the strength of the pavement or other known factors, and you have the the masts with pistons that you drop on a load cell, and there's a rail that you set on the ground, and once you have the vibrations, depending on the stiffness or the thickness of the layers, it causes a certain response, which is then recorded in the CPU and transferred into the computer, which is connected by the data cable. Mhm. So essentially, the FWD or HWD is used to verify pavement layers. So the whether not, first of all, whether the number of layers that you have, the individual layer strength, and of course, just recently we were on a project where we were actually verifying the pavement standards as to whether the individual pavement layers, subgrade, subbase, base course, and asphaltic base course, whether they actually met the design standards as set out by the design consultant. So basically, for on behalf of a contractor, this was being used to do those verifications. However, similar to the profilometer, it can also be used on existing roadways to actually verify the residual pavement life. So for example, you may have a roadway that's 10, 15 years old and little to no signs of distress, but you run your FWD on the roadway and lo and behold, okay, compared to design strength, you may be seeing a 20% degradation. Well, of course, if we call the pavement deterioration curve, once you get onto that level of once you get onto that curve and you start sliding, then there's no stopping until such time as some level of intervention is made. So in addition to other pieces of equipment like a ground penetrating radar and so on, you typically use this to understand what is happening on the subsurface, right? And essentially, as I mentioned, it's an impulse type piece of equipment, so that once you drop the hammer, the response creates what is called a deflection basin. So when that basin forms and um, the geophones pick it up, then it determines what sort of strength you have on the individual layers. Okay. Um, this piece of equipment, the FWD, is considered the gold standard in assessing subsurface strength. Not the DCPs, not the coring, not the test bits, but actually this gives you the response that you get from the pavement actually gives you the in situ, the real-time strength that you actually have from the layers that are in place. Because the DCPs, you would have to do some disturbance of the surface. You can't get the true reflection of the entire pavement structure, and of course it doesn't it doesn't assess the entire pavement in one go. You have to assess each of the individual layers, hence the true response of the pavement isn't there. So the DCPs are the closest thing to this, but from the surface you get everything that you need to get from the pavement. So this, as I said, is the gold standard, and um, has been used successfully on a number of projects that we have worked on, and it has been used to verify results of works done by contractors, international contractors. Okay. Um, Final slide before I hand you back to the moderator. This is just an example of the use of the equipment on the runway as I described before. And, it was actually, this was prior to some rehabilitation work on the runway, which when completed actually is found to actually be in such a condition that the redesign could have been tweaked a bit to save some money. So for those of you clients amongst us here, I'm sure that is good news for you, in that understanding that you have some trusted and reliable piece of equipment that can actually tell you whether or not your equipment can actually, or your piece of infrastructure is in such a condition that it does not require the extensive remedial works that may have been undertaken otherwise. I'm sure a pretty significant piece of information that you would want to have. And I'd also just like to close by saying as well that the key to it, whether you're using the FWD, a ground penetrating radar, or the laser profilometer, is that you must be regularly collecting your data. And don't think that because your infrastructure is fairly brand new, that you can simply walk away and wait until such time as you see the deterioration. At that stage, the old adage goes, a stitch in time saves nine, and it's no different with the testing equipment that we have. I mean, I don't know if I have any colleagues here from Tobago, for example, but we would have done some axle testing, for example, back in 2019 on the Claude Noel Highway. And lo and behold, the design that was being offered for rehabilitation of the road network um, proved to be way above what was actually required, right? So that was one piece of savings that the THA would have had at the particular point in time. We would have done some traffic surveys, even for example, around the Crown Point Airport for the expansion project, which, when we would have done a previous survey some years previously, based on the projections, we would have found that the traffic condition would have increased exponentially, or would have been an underestimation of what um, that present day situation was. So the point I'm making is that um, we can't simply relax and rely on information that was obtained maybe 20 years ago, or information maybe 5 years ago, or the fact that we have something brand new that we expected that it would last based on the antecedent conditions at the time. We must do our homework and to ensure um, that our infrastructure lasts, stands the test of time. And over the years, using various forms of equipment, whether our personal equipment or using it as advisors to clients, we have seen the benefits of it, the relative expense associated with it, and the long-term results that have been achieved by it. So with that, I think I will close and take any questions, hand you back over to the moderator. Thank you very much for your time.
All right. Thanks so much, Mr. Williams. Does anyone have any questions? Please feel free to raise your hand using the hand icon at the very top, and we'll be sure to we'll give you the mic. Just in case anyone has no questions just yet, I did have a couple pre-advanced questions from the registration. I know, Mr. Williams, with respect to the testing and the testing methods, one of the questions was, what's the reliability of this testing regarding the age of the road surface?
Reliability as it relates to age.
Yes. Anything with respect to that?
Well, I hope I understand the question correctly. Is it that there's a concern about whether the test is reliable for older pavements? Is my interpretation correct?
Yes, I believe so.
Yes, as I indicated, you can also use it on existing pavements to understand, for example, where you may be on the deterioration curve. So if I would use the example of the FWD, let's say you have a pavement that is 15 years old and may not be showing signs of deterioration just yet, or maybe in some preliminary stage of deterioration. You would have had a design for the particular pavement, and you run your equipment. You can then determine what the difference is in the residual strength, or the strength of the existing strength of the pavement layers as compared to the design strength, and then that way you can understand what level of deterioration you may be experiencing on the particular roadway. So yes, it can be used on new pavements or old pavements.
All right, thanks for that. So I did have a couple more questions. So one of the other question had to do with the material and how NDT, if it has any effect on composites. Now, I did reach out and just to clarify, what they meant by that, with respect to new materials coming online and those things, how does the NDT methods right now, what is the feasibility with respect to using, with respect to being used for newer materials coming on?
Okay, that's an excellent question. So I'll use two pieces of equipment. So the profilometer, essentially you have no issues with respect to new materials, because essentially it just gives you, you know, whatever is there, whatever is there, you get whatever is there on the surface, whether it's a crack, it's a rot, as the case may be. The FWD, on the other hand, depending on the surface that you use or the material that you're using, there can be a number of different approaches that you must take. So, for example, cement stabilized materials, for example, or rubberized asphalt, the um, the behavior or the response to the impulse loads, can vary significantly from the traditional pavementized, where you have strictly the asphalt, the base course, asphaltic base course, the granular base course, as the case may be. So yes, there are different materials, and there must be, and this is where the expertise comes in with the analyst, that there must be someone who is experienced enough to readily interpret the data in a way that it can be, to give a fair reflection of what the subsurface is. Yeah.
Right, thanks for that. So I see that we do have a question from Jalen. Stephen, please feel free to turn on your mic, and the floor is yours.
Hi, good day, everyone. So thanks for that lovely presentation, Mr. Williams. My question to you is, based on the methods or techniques that you highlighted, which would you say is optimized for secondary roads in particular? Because I know some of them might be suitable for, let's say, airports, highways and stuff like that. But, secondary roads, you may have limitations in terms of access and just the road user, the user friendliness of the road altogether. So I would like to hear what is your thoughts on that.
Okay, for secondary roads, particularly in Trinidad and Tobago, and assuming you will be referring to some of the more difficult roads we may experience in certain areas, I would most likely recommend the ground penetrating radar and the profilometer. Why? On a lot of our secondary roads, you also tend to have utilities in place, and sometimes the utilities may not be at the depths that you expect them to be. So, or in the location and the planned location. So if you were to use the FWD on some of these roadways, you may encounter some problems. In addition to which, the FWD is really meant for, should I say, designed roadways, right? And the way a lot of our secondary roads have come into being is, they have essentially evolved. So if you don't have the stratified layers going from strong to weak, then you may have responses from the FWD that are difficult and near impossible to interpret. So for me, and then again, it's not going to tell you anything that you don't know. So my suggestion in that case would be to understand what you have on the subsurface by using the ground penetrating radar, coupled with the pavement condition survey with the profilometer, to understand whether or not you're in an acceptable range, particularly with things like the shape, the cross-sectional shape of the roadway. Those tend to be major issues in the secondary roads, as well as the things like the skid resistance for safety and so on, because some of them, when you can do cores of the aggregate of the asphalt, sometimes you see the aggregate is probably not where it should be in relation to the specification. Yeah.
Right.
Thank you very much.
Right. Thanks, Jalen, for that question, and thanks, Mr. Williams. So I did have another question here, and that had to do with prediction. Now, the extension to that question was, we're getting a lot of data testing from the NDT tests, with respect to cracks, with respect to different profiles, and right, and with respect to using that data to kind of get a prediction model of how or what is the right kind of compositions and parameters is what is the term that they used to creating and paving those roads properly in order to reduce the chances of those cracks. Has anything like that been underway in terms of using existing NDT data to create those kinds of predictions?
Look, in the region, not really, but it can be. So, for example, just like the data basically drives the solution, right? So, if you were to discover that, for example, you have severe cracking on your roadway, and okay, you want, let's say, your pavement is in the 10th year of existence and expected to last 20 years, then depending on where you are, then you may determine that, okay, I may need some crack sealing and an overlay, and that may arrest the problem, or I may need to use a geotextile, for example. So yes, but I have not seen, again, because it's something that is being used sort of sparingly in the region. I can't give you examples in the region per se, except for one or two places which they're still they're just getting up and going with. But outside of that, my other experiences that are seeing it are actually in the States, and quite effectively. So that I can only speak from that, not from the local experience, just from the international experience, observations.
Okay, well, I hope some of that comes here, because the amount of cracks we have, especially in Trinidad, it needs some better predictions in order to prevent that. So does anyone have any other questions? Feel free to raise your hand, turn on your mic, and ask away.
Right. Well, if I may, while we wait on the questions, I'd just like to share some of the experience in Guyana, which we are actually supporting in their work. In that they're they're going to be starting a significant program in testing using the profilometer, actually, for verification of all of their projects. And if you all understand, Guyana is, they're on that major development drive. So doing, for example, 120 kilometers of new roadway, which is like a quarter of the way to Brazil. So, testing is both the FWD and the profilometer being used on that project. There are some other projects, 70-something kilometer rehabilitation. So they have embraced the concept that this thing needs to be done, and actually actively involved in utilizing the technology to ensure that they get the best value for money. Because I mean, when you're talking those types of numbers, you can't be doing it twice and three times. You have to do it once and get it right the first time.
It makes a lot of sense, especially like you said, with respect to the budget, it can be very sensitive, and you don't want to, make any mistakes, especially with respect to potential lives at stake that are using those roads and those ways every single day. Right. Does anyone have any questions with respect to what was presented, what was discussed? All right. Well, in case anyone has no questions, or may have some questions subsequent to this meeting, Mr. Williams, is there any email that they can reach out to you, or any kind of contact that you would prefer?
Sure. You can reach me. I'll type it into the chat.
Sure.
Very easy. Lacey@caritransltd.com. LACEY at Caritrans, CARITRANSLTD.com. Oh, someone has a question.
Yes. So I believe that is. I can't remember the name, but yes. Please go ahead, Shandell.
Oh, it's Shandal.
Shandell. Okay. Apologies.
I know that you mentioned that there's a cost difference between the destructive and non-destructive methods. So I just wanted to know if you like have an exact figure or an approximation of what the differences are.
No, I don't have exact figures, and it just depends. What I can tell you in terms of, I can give you figures in terms of man hours and the ancillary cost that you incur. So, for example, police extra duty, right? If you, in Trinidad and Tobago, if you want to do any works that will disrupt the traffic flow, you would have to hire police to, control traffic. And so I have those costs. So, for example, you'll have to hire them for a minimum of 4 hours. I don't know if that's gone up to 6 hours. Two constables and a corporal may run you to anywhere between, I think it's about $400 an hour or so, if I'm not mistaken. And sometimes if you had to do a day's worth of work, you can end up anywhere between, depending on the stretch, between a few $1,000s to maybe in the 4-digit region. Sorry, into the 5-digit region. Yeah. At one time I paid, that amount, and that's just for the police alone. In terms of staff man hours, you would probably want to have either a senior technician or an engineer on site, and the cost for that individual to and from the office, and and maybe a technician or two, that'll probably cost you on a daily rate somewhere between, again, upwards of about 10 grand a day, right? So you just work on the math for, if it's half a day as the case may be. So essentially, that that cost for the equipment, of course, taking into consideration wear and tear on equipment, you'll probably, for a small project, probably incur about maybe half the cost, but as you go along, you start getting the economies of scale. So the cost difference will only widen as you go longer. So just consider those. Again, don't quote me as exact figures. That's just rough order of where you'll actually be from small to large type projects.
Okay, I understand. Thanks.
All right. Thanks, Chandel, and thanks again, Mr. Williams. So just to reiterate, the contact information is Lacey at Caritrans. What's the extension?
LTD.
MTD. LTD.com. Okay.
Yes. CARITRANS LTD.com.
Excellent. All right. So if anyone has any questions whatsoever, please feel free to reach out to Mr. Williams in case you do have any questions subsequent to the meeting. So once again, Mr. Williams, heartfelt thanks for presenting today. I know that you would have exhibited a lot of information. And once again, we have another question. So yes, go ahead, Jalen.
Okay, thanks again. And last question, one to you, Ezekiel. I would like to know if this recording will be available after. And then the last one to Mr. Williams is the laser profilometer, right? If I'm pronouncing it correctly. Is it available locally? How much is it like one supplier has it, or do you find that the market is gravitating towards that technology locally in Trinidad and Tobago?
Yes, and yes. So yes, it's being embraced locally. Yes, it's being used locally, and yes, I am the only supplier. Sorry, just have to be out there. There may be in the future, but for now, yes, we are in fact in the region actually. We are the only supplier in the region. So yeah.
Okay, that's great, man. Keep up the good work.
Yes, we are actually just gearing up to do some evaluations for a state agency because we haven't signed on the dotted line just yet. I don't necessarily. It's one of your partner agencies, Mr. Stephen, But you should be seeing equipment on the road extensively over the next few weeks as they want to roll out their program of assessment. So.
All right. So thanks again,
Okay,
Jalen.
great.
And right, and also to answer your other question, yes, this recording will be available. It will be available on Appet's YouTube page, as well as their social media pages as well on Facebook and LinkedIn. So you could always type in Appet or Association of Professional Engineers of Trinidad and Tobago, and you should be able to check it out. If not today, then tomorrow, once we have the video processed as well.
Okay, I just have a question there for those of you who may be the clients on the call. What's your take on the maintenance of roads locally? How satisfied you may be, and where do you see um, Trinidad and Tobago going in general? Because interesting, we get different perspectives from the respective clients across the region. But what is your general feel, if you're willing to share, on how that is, and how the situation is locally?
All right, Ryan.
Good afternoon, everyone. Mr. Williams. So I'm from Tobago, and based on my observation, there's one thing that annoys me a bit. There would be certain areas in Tobago where they more or less resort to patchwork, but within a few months' time, those exact same spots keep on deteriorating. I know one of the reasons for that is water intrusion. From the time there's a crack and water gets in there, I always say water is one of the most powerful elements because all it requires is time for it to do its work. So I think from that perspective, better can be done when it comes to certain roads. And then within the context of Trinidad and Tobago, in comparison to other countries abroad, where I think they design the roads according to the type of vehicle that traverses on those roads. I know in some places, for example, in the UK, they will have those 40-foot trailers, etc. They have a specific lane that they will travel on. I presume that specific lane is designed, the layers may be different from the other lanes where the normal light vehicles will travel on. So I think from that perspective, we have to look out there and see what it has that could be adopted to our road networks, because maintaining a vehicle is very expensive in this day and age. Very expensive.
Yeah. All right, thanks for that.
Allow me to chime in case anyone else, is willing to also add. One of the things that I also wonder is whether or not there is some room, or if they implement some as part of the budget, be it whatever location or contractor, to do further maintenance or upkeep, because that's one of the gaps or challenges, especially that we face locally, maintenance. In addition to that, I do wonder as well, as part of their methodology for their construction model, if some of the things that, for example, Mr. Melville had spoken about with respect to water and its impact on it, how much of a relative weighting that has on the conditions of the road. Because, I mean, we see it all too well and all too frequently that we don't, and it's surprising that, I would think that we have enough data based on past analyses to update our construction models to reduce the chances of these occurring. Even if, for example, pave a road and WASA has to dig it up, Even if that has to be the case. One would think that, we have is so much data to re-implement it into our construction models to prevent these kinds of things from occurring. And does anybody have any other comments or questions? Feel free. All right. Well, otherwise, once again, Mr. Williams, we thank you so much for your presentation and insightful information. We thank all APAT members and prospective members who have taken the time to participate in this technical seminar. And of course, look out for more seminars from Mr. Williams to come. I'm giving you that opportunity to present if you are so willing to do so at any time as well. So, of course, thanks again to all the organizers, the Tobago chapter, who, would have put us on, to Mr. Williams as well. And of course, thanks everyone for coming. And I hope you all have a wonderful Thursday. Keep in mind, of course, that we are going through Engineering Week. And of course, the last event that we are having to conclude everything is going to be on Saturday. That's at the TTGPA office. That's near Hazley Crawford Stadium in Trinidad, in case you can make it from 1 p.m. to 6 p.m. Right? So bring your friends, colleagues, anyone that you may know that may be interested in networking, and we'll be happy to have them. Very casual event, just to network, just to get everybody, in one spot to get to know everyone. So we hope you all have a very pleasant and productive and relaxing evening. And that will conclude the end of this technical seminar. So take care, everybody.